Hello and welcome to another episode where we shall be looking at the proposed memorandum for Physical Sciences Paper 1 for grade 10. That's in November 2024. Okay, it was for some district that wrote it, so you can just use it, and for people that have not yet written, you can probably use it as a revision guide, okay? It's just the proposed memorandum. So let's see. So we had 2 hours to complete this 100-mark paper. Okay, we have 8 questions, okay? Multiple choice, multiple choice, multiple choice, multiple choice. Which of the following indicates a wave in which the particles of the medium vibrate parallel to the direction of motion? Okay, so the best option here was D, which is the sound waves. Then which one of the following combination below concerning pitch and loudness of sound is correct? Okay. So pitch depends on the frequency. Pitch depends on the frequency. So I'm going to look at option A and B because I have the frequency. Then loudness does not depend on the speed. It depends on the amplitude. So option A would have been the best. 1.3, the physical quantity with both magnitude and direction is what we call a vector. So vector is option A. Then 1.4, a car is traveling at a constant velocity, which is just a straight line or a horizontal line. And then it slows down uniformly. To the following is option C. Then there's a charged sphere that is placed on an insulating stand. The learner is holding a second charge, which is hanging from a string, as shown below. If a learner releases the sphere, so both spheres have positive charges, and we know that like charges will repel each other, or the same charges tend to repel. So it will swing away from the charged sphere placed on the stand. That's okay. Remains the same position. Nope. Swings towards no, become neutral. So A is the best. 1.6. All light bulbs are the same within the following circuit. In which circuit will the ammeter reading be the biggest? So from Ohm's law, okay, which is V is equal to IR, we know that current, since we're looking at the same number of batteries, so voltage is definitely out. Let's compare it to the resistance. Okay, so current is inversely proportional to the resistance. So the circuit with the minimum resistance, that should be the circuit with the biggest ammeter reading. So series combination, that's not going to work. Okay, we know the current is just uniform. And then in this case, the resistance is higher. Parallel and series, okay, not so bad. But we're seeing that this is going to be the worst. Like number last. Or let me just label it as number 4, because it has the highest resistance. Then number 3 is going to be this one. Because if I combine this and this, they are in series, which increases the value. By the time I apply that, is some bit of slowness, okay? Then this and this, I'll call it number 2. But then this one is the big deal, because all the bulbs are connected in parallel. So if we assume that we have, let's say, okay, let me assume that everything was 2 ohms, which means the total resistance here will be 6 ohms. Here we shall have 2 and 2, which is 4. This is 2. So product over the sum, which is 8 over 6, that becomes 4 over 3. Down here, it will be product over the sum, which means it's going to have just 1 ohm. Now here, 1 over 2, 1 over 2, and then 1 over 2. This becomes 3 over 2. Change that, switch it around, which is 2 over 3. So this gives us the smallest of the resistances, which means there's more current within the ammeter. So option D would be the best. 1.7, if we consider a pendulum that is swinging in the vacuum, at which position is the mechanical energy maximum? Now we know that mechanical energy is the combination of the kinetic and then the gravitational potential. Okay. Now, if it so happens that we're talking about the vacuum, which means there is no extra force or there is no extra air or wind that's going to cause a disturbance to the energy that we already have, meaning that energy is going to be conserved within this system. So the mechanical energy here must be the same there, it must be the same there. As much as here we're going to have the EP max. At this point, we shall have the EK max, and then at this point, we shall have the combination of the two. So for mechanical energy, all the bodies or all the positions will have the same energy. So that is how I would have gone about the 14 marks, okay? Question 2. They want us to define what a pulse is. So we know that a pulse is just a single disturbance. Okay, it's a single disturbance that travels through a medium. Single disturbance that travels through a medium as it transfers energy from one point to another. Okay, make a labeled sketch to represent the two pulses when they meet at point Z. So we know that for X, it's going to be something like that. And then for Y, it should be something like that, slightly bigger. So this is Y, that is X. Okay, 5, and then that is 8 negative. All right, then what type of interference? Since they are moving in opposite directions, this must be a destructive interference, okay? And then how will the amplitude of X change after the interference with pulse Y at a point Z? Is it going to increase, decrease, or stay the same? Now, since the amplitude of this one is smaller than the amplitude of this, it has to decrease. It's going to be destroyed so that it decreases. Then the distance between 9 consecutive wave crests of a transverse wave is 16. The wave travels at a speed of 0.5 meters per second. They want us to define what a transverse wave is. So it's a wave in which the particles vibrate perpendicular to the direction of motion. Okay, a wave in which the particles vibrate perpendicular to the direction of motion. Then calculate the wavelength in meters. So this is 2.6. So we know that wavelength, which is the lambda, should be the, how many waves are we talking about? Okay, we have 16 as the distance, 16 centimeters, divided by how many waves are we going to have from 9 consecutive. So 9 consecutive will give us 8 waves because it's 9 minus 1. So this becomes 2 centimeters per wave. Change this to meters, which is 0.02 meters. Then 2.7, they want us to get the frequency. They give us the speed. Okay, we know that frequency is the reciprocal of the period. Okay. Well, that makes sense though. If I use V is equal to F lambda, will that make sense though? I can use this one. I can keep this one for the last question. Okay. Let's use V is equal to F lambda. They want frequency, which means it's the V over the lambda. So the speed is 0.5 divided by the wavelength, which is 0.02. So this gives me 25 hertz. And then 2.8, they want us to get the period of the wave. It's 1 over F. So 1 over 25, this gives us 0.04 seconds. So that is how question 2 would have been approached. Question number 3. When a patient has a broken rib, doctors opt for a rib fracture fixation surgery to manipulate the ribs into better alignment. This surgery will minimize a number of complications such as uncontrollable pain, respiratory failure, as well as pneumonia. Below is an illustration of a picture taken after the operation. So we know that this is an X-ray. Not X-ray, it's X-ray. So what type of electromagnetic radiation are used to take such images? So we said it's X-ray. Then is the frequency of the X-rays greater, equal, or less than the gamma rays? So we know that the X-rays will always have a frequency that is smaller. Okay. Then 3.3, the frequency of the X-ray is this much. Calculate the energy of the photon of the electromagnetic. So we know that for us to get the energy of the photon, we can use this formula. So E, we know that H is Planck's constant, which is 6.63 times 10 to the negative 34. They gave us the frequency as 5.8 times 10 to the 22. So punching that into the calculator, I'm ending up with 3.85 times 10 to the negative 11. It's energy, so it's going to be just joules. All right, then can we define what frequency is? So frequency refers to the number of complete wave cycles or waves, okay, that pass a given point, that pass a given point a unit of time, or the number of cycles of a period of time. Then next, the amount of cell phone users has increased in the last decade. Research claims that the radiation emitted by the cell phones can affect living cells. There is a close link between the amount of cell phone radiation a person is exposed to and then the increase of brain tumors, eye cancer, birth defects, hearing loss, as well as the loss of balance. So what type of electromagnetic radiation is used within the cell phone signal? Okay, so we know that cell phones, TVs, radios, blah, blah, they all use what we call the radio waves. Okay, so which 2 precautions can you take to minimize the amount of cell phone radiation that one is exposed to? Okay, so what we can say is that we can limit the duration. Okay, limit the duration of cell phone usage. But this is kind of hard to control. As people are addicted to their phones. 2, we can use earphones. So earphones or headsets when making calls so that we avoid the direct contact with the cell phone signals and so on and so forth. So 2 precautions, that's what we can do. But like it's hard, you can't tell me to limit the duration. So like how, why? It's my phone, hello. All right, question number 4. A baby leaves a bowl of food on the floor. This baby crawls westward to fetch the toy that is placed 5 meters away. At the same time, there's a dog that is walking eastward towards the baby. It takes 30 seconds for the baby to reach the toy. The dog walks past the toy to eat the baby. Dog wants to eat the baby's food. It's not fair. It's not fair. Okay, 4.1. Can we define the term displacement? So we know that displacement and distance are more or less the same thing. but it's more of the change in position, but in a particular direction, okay? Direction must be specific when it comes to displacement. Distance, it's just in everywhere without any sort of direction. Then 4.2, determine the position of the dog relative to the baby before they both start competing to move. So that's going to be 7 plus 5, which gives us 12 meters. Then the average velocity of the baby, so we know that speed is distance over time. Okay, so velocity, the velocity average is going to be the change in distance, or it's going to be the displacement, since it's velocity, displacement over the time. So that displacement that the baby moves, where is the baby going? The baby wants to get the toy. So it's 5 meters over 30 seconds. We need to change that from, no, it's fine. We can use it like that. So what's 5 over 30? 5 over 30. That gives me 0.167. We can say meters per second. Question 5. This question is loved. Very, almost every year is a question like this. Okay, velocity time graph of a racing car moving eastwards is shown below. Can we define the term acceleration? So we know that acceleration is the rate of change in velocity, or it's the change in velocity over a period of time. That is acceleration. So delta V over delta T, that is acceleration. Okay, write down the magnitude of the initial velocity. Where is the graph starting from? Wow, 30. So that is 30 meters per second. Can we describe the motion of the car between C and D? So it's seen that between C and D, the car is decelerating at a constant rate. Or we can say that the car is slowing down. Okay, so car slows down at a constant rate. So slowing down at constant rate simply means you're going to have negative acceleration. So can we support the answer that we have in here using calculations or by calculating the acceleration? So we know that acceleration is V final minus V initial over the change in time. We can use that, or alternatively, we can start by stating that formula of motion or that equation of motion and say that the V final, okay, we're saying V final is equivalent to V initial plus A delta T. So our V final at D is 0, okay? The V initial from C is 40 plus the A multiplied by the time that it takes, means from 20 to 25, which means we have 5 seconds there. Let's move the 5 that side and the A, so it's negative 5A is equal to 40, divide both sides by negative 5, that gives us negative 8 meters per second squared. That's all they wanted, the negative part there. The negative is what they wanted. All right, 5.2, a delivery van is traveling at a constant speed of 15 meters per second in a 60 kilometer per hour zone. When a driver sees people walking across a pedestrian crossing, which is 50 meters ahead of him, the driver takes exactly 1 second to react. He applies the brakes as hard as he can, and it takes him a further 3 seconds for the car to come to a stop. Then 5.2.1, they want us to convert 60 kilometers per hour. So 60 kilometers per hour is like 60 kilometers over 1 hour. Let's change the 60 kilometers to meters, multiplied by 1,000. So that's going to be 60,000, and then this is going to be 3.6, because it's 160 minutes and then 60 seconds. So simplifying that, it's going to give me 16 0.67 meters per hour. So this driver was within the right range, okay, because it was moving at a slower pace compared to the maximum. Okay, then calculate the distance that the delivery van travel during the reaction time. They want the distance. So we know that distance is going to be speed times time. Okay, so the speed is 15, the time is 1, which means it's going to be 15 meters. That's what the van travels during the reaction. Then will the van stop before the pedestrian crossing? That we don't know. Let's prove. Let's prove and see. So the van is going to travel an extra 3 seconds. So let's get the distance via which the van traveled after the brakes were applied. So we know that the final velocity is going to be a 0. Initially, it's going to be 15. Okay. Now our time, I'm going to take it to be 3 seconds. And then I need to look for the displacement. So I can say delta x is equal to the initial delta t plus a half a delta t squared. So that's 15 times 3 plus, that's a half, our acceleration was negative. Whoa. Did we get the acceleration? Yes, we did. Oh, but this one was for that side. Oops, we don't have the acceleration, which means we need to start by getting the acceleration. I think all the equations of motion have acceleration. Okay, so V final is equal to V initial plus A delta T. So the change is 0 is equal to 15 plus A into 3. Move the 3 that side, negative 3, A is 15, which means A is negative 5 meters per second because it is decelerating. Okay, so I'm going to replace this here and then multiplied by the time, which is 3. Okay, so this is going to be 45 minus 7,5. So 45 minus 7,5, that gives me a 37,5. So this is how much the car is going to travel for those extra 3 seconds. But now, initially, we had the reaction time where the car traveled 15 meters. Okay, so if we get the 15 meters plus the 37,5, what do we get? Whoa, something is off, something. I did not square this, I don't know why. I did not square that, so which means that is wrong. So it is 45, that's 9, which becomes 22,5, okay? So that is a 22,5, which means even this one is gonna be a 22,5. And then the addition is gonna be 15 and then the 22,5. So it becomes a 37,5 meters. So we can see that the 37,5 is smaller. Okay, it's smaller than what do you call that then, the 50 meters. So this guy stopped before the crossing. All right, question number 6. 2 identical insulated graphite coated spheres are suspended from threads. The spheres are held a small distance apart. So Q is having negative 2,4 nanocoulombs. This is 5,6 nanocoulombs. When the spheres are released, they move towards each other, attraction. So explain why the spheres move towards each other when they are released. Okay. So we're going to say that unlike charges, attract each other. Or the charges of opposite signs will attract each other. Then the two spheres now touch. What will be the charge on each? So let's get the 5,6 nanocoulomb plus the negative 2,4. The answer we get, we divide it by 2. So punching this into the calculator, I'll end up with 1,6 nanocoulomb. So this is the charge after the separation, because when they are separated, they each must have the same amount of charge. Then they want us to get the number of electrons, okay? So we know that N is equal to P over E. So number of electrons that were transferred from one sphere to the other. So for us to get this, we need to see that from 5,6 to 1,6, how many electrons were lost? It's 4 nanocoulomb, okay? So where there's Q, I'll say 4 times 10 to the negative 9 over the electron charge, which is 1,6 times 10 to the negative 19. Punching this into the calculator will give me 2,5 times 10 to the 10 electrons. All right, so that is that. Then 6.3. Which way will the electrons move? Is it from P to Q or Q to P, or neither? So usually, electrons must move from a congested area to a less congested area. In other words, a more congested to a less congested area. So they have to move from the negative side towards the positive. So I'm going to say from Q to P. Now, what is the reason? We're going to say that Q is more negative. Q is more negative than P, which means that electrons will flow from Q to P, or from a more negative to less negative. Question number 7, circuit below shows a battery with minimal resistance, 2 ammeters, A1 and A2. Then 3 resistors, the A1 is 1 amp. All right, what is electric current? So electric current, which is I, Q is equal to IT. So I is Q over T. That is the rate of flow of charge. The rate of flow of charge across a conductor. Okay, a rate at which charge is flowing across an electrical conductor. Then 7.2.1, they want us to get the effective resistance of the parallel. So this is the parallel, okay? So with the parallel, since there are 2, I can get product over the sum. So 12 times 6 over 12 plus 6. And I simplify that, I'm just gonna get 4 ohms. Alternatively, you can use your 1 over R, this 1 over 6, plus 1 over 12, and then you flip it around. It should give us the 4 ohms as well. Then 7.2.2, they want us to get the total resistance. So total resistance will be the 4 ohms plus the 18 ohms, because now these will be in series. So 4 plus 18, that becomes 22 ohms. 7.2.3, they want us to get the amount of charge that is passing through A2, okay, in 5 seconds. So we know the current through A1. We don't know the current through the. So let's start by getting the voltage across the 6 ohm. This is 7.2.3. Okay, 7.2.3. Voltage across the 6 ohm is going to be IR. So it is 1 multiplied by the 6, which is 6V. But since the two resistors are in parallel, which means the voltage is kept the same, okay? So which means even this 12 ohm is having 6V as its voltage. Let's get the current there. So the current across the 12 ohm from Ohm's law is going to be V over R of 12. So 6 over 12, which gives us a 0.5 amps. Now, the total current, okay, A2 is going to be the sum of the 0.5 plus the 1, which gives me 1.5 amps. The question is asking for the amount of charge. So we know that charge is given as Q is equal to IT. So 1.5 multiplied by 5 seconds. Is that true? Is that true? I don't know. We don't know. 6 divided by 12 is 0.5. Beautiful. So 1.5 times 5, 7.5 coulombs. 7.3, how does the potential difference across the 6 ohm compare the potential difference across the 12 ohm? That is equal to. Why? Because the 6 ohm and 12 ohm are in parallel. And with the parallels, the current that is different, voltage stays the same. Question number 8, and probably the last one. An object that is having a mass of 0.2 kilograms is released from point A and moves along a frictionless section of AC. Along CD, it experiences friction and then stops at D. The vertical height is 0.8. What is the principle of conservation? So saying that in an isolated system, the total mechanical energy is conserved, or the total mechanical energy remains the same. All right, 8.2. They want us to get the gravitational potential energy of object at point A just before it is released. So EP of A is going to be given as mgh. M is the mass, which is 0.2. G is 9.8. The height is 0.8. So punch that into your calculator. This is going to give me 1.57. This is energy, so it is in joules. Then 8.3. At point B, okay, the speed of the object is 3 meters per second. Can we use the principle of conservation mechanical energy to calculate the vertical height? So we need this height. So one thing we need to know is that at A, the object is at rest. So which means it is just having the EP max. But then at B, since it is moving, it has some bit of velocity. So there's going to be some EK plus some EP. And then at the bottom here, we shall have the EK max. Now, energy will stay the same regardless of the phase. It will just change from one form to the other. So down here, I'll say that the EP max should be equivalent to the EK at B plus the EP at A. So the EP max that we got was 1.57. This is at A, is equal to the a half m v squared. And then this is a mgh, looking for the height of B. Let's do the substitution. 1.57 is equal to a half times 0.2 multiplied by 3 squared plus 0.2 times 9.8 h. So 1.57 So simplifying that side, we shall have 0.5 times 0.2 times 9, which is 0.9. Plus, we have 9.2. No, it's 9.8 times 0.2, which is 1.96H. So let's move the 0.9 to that side, which will be a subtraction. So 1.57 minus 0.9. This is 0.67 is equal to 1.96H. So divide by 1.96 over 1.96. That cancels that. So the height becomes 0.67 divided by 1.96, which becomes a 0.34. All right, so guys, that is that with that paper, and I'll beg to stop at that particular level. But let's quickly go over this again and see. Okay. So did I even square that? Oh Lord, what's wrong with me? So 1.57. Okay. That's 0.5 times 0.2 multiplied by 3 squared, which is 0.9. Perfect. And then, okay. So I think that is that. It makes logical sense, which is 0.34 meters. So guys, that is all with me. Let's just hope you guys have a fruitful preparation for your paper 2, and those that have not yet written paper 1, we wish you all the best in your final exams. Bye-bye.